Step into the realm of agricultural marvels as we unveil an array of technological wonders that are transforming the way we cultivate the earth. In this video, we unveil a captivating lineup of machines and tools that harness the power of automation and data-driven insights to redefine farming practices. Discover the ingenuity of smart greenhouse systems that create optimized microenvironments for plant growth, the efficiency and precision of automated poultry feeding systems, the power of crop yield monitoring technology in fine-tuning farming practices, the meticulous application of nutrients using precision nutrient applicators, and the robotic planting machines that replace manual labor with unparalleled accuracy. Together, they illuminate the path to a future where farming is a fusion of human intelligence and technological prowess. Number 5. Smart Greenhouse System. The term smart greenhouse system refers to a cutting-edge and fully automated piece of equipment that is installed in a greenhouse in order to monitor and manipulate the many environmental conditions present there. The temperature, humidity, light intensity, levels of carbon dioxide, CO2, soil moisture, and nutrient levels are some of the environmental characteristics that may be monitored by intelligent greenhouse systems through the utilization of a network of sensors. These sensors supply the system with data in real time so that it can do analysis and control. Automated control mechanisms are utilized in intelligent greenhouse systems in order to fine-tune environmental conditions according to a set of predetermined parameters or desired crop-specific requirements. This involves the control of systems for shading, heating, ventilation, and cooling, as well as irrigation and nutrition supply. The climate parameters of the greenhouse, such as temperature and humidity, are modified by the system so that plants are provided with the best possible conditions for growth. It makes sure the temperature stays within a certain range and changes the humidity levels so that there isn't either too much moisture or not enough moisture to cause tension. In order to control the amount of available light, intelligent greenhouse systems make use of sensors and actuators. This involves changing artificial lighting systems to supplement natural light, controlling shade systems to optimize light intensity, and applying light spectrum management for various growth phases or crop requirements. These are just a few of the many things that fall under this category. The process of irrigating the plants is made easier and more accurate by these devices, which also ensure that the plants receive the appropriate amount of water at the appropriate intervals. Some of the more advanced greenhouse systems also feature nutrient delivery systems, which monitor the levels of nutrients in the soil and provide accurate dosing to ensure that the plants receive the best possible nourishment. Number 4. Automated poultry feeding system. A mechanized system that is meant to automatically give feed to chickens in a manner that is both controlled and efficient is referred to as an automated poultry feeding system. Feeders for chickens, turkeys, or ducks are used in automated poultry feeding systems. Feeders for other types of poultry, such as ducks or geese, are also used. These feeders are made to keep and dispense feed while reducing the amount of waste, contamination, and spillage that occurs throughout the process. A feeding schedule has been built into the system so that it will distribute feed in accordance with that timetable. This plan can be adjusted depending on the poultry's age, size, and the specific nutritional requirements they have. At predetermined intervals, the delivery of feed is prompted either by automated timers or sensors. Storage bins or hoppers are typically a part of automated poultry feeding systems. These are the places where the feed is kept. After that, the feed is brought to the feeding stations by means of various kinds of mechanical mechanisms such as augers, conveyors, or pneumatic delivery systems. The birds will always have access to a steady and well-managed supply of food thanks to these technologies. Some of the most advanced automated feeding systems contain software for feed management, which enables poultry producers to monitor and modify feed quantities, feeding schedules, and nutritional programs using the system. This helps optimize feed efficiency, which in turn reduces costs and ensures that the bird's precise dietary requirements are met. Poultry feeding systems that are automated are intended to make it simple for the birds to get their food, while also minimizing food waste and the risk of contamination. Feeders can have obstacles or mechanisms built into them to regulate the entry of birds and minimize the amount of feed that spills out. It is essential to feed poultry in a clean and hygienic manner in order to protect their health and maximize their production. Automated feeding systems frequently incorporate components such as feed-level sensors, feed rotation mechanisms, and components that are simple to clean in order to maintain good feed hygiene, reduce the risk of feed going bad or disease transmission, and assure adequate feed hygiene. Number 3. Crop yield monitoring technology. The term crop yield monitoring technology refers to the application of a variety of instruments and approaches in order to quantify and evaluate the yield or output of crops grown in agricultural areas. The technology behind yield mapping makes use of the Global Positioning System, GPS, as well as yield sensors that are attached to various pieces of harvesting machinery, such as combines and harvesters. As the machinery goes over the field, the sensors take accurate readings of the crop yield in real time. This allows for the creation of a yield map that illustrates the spatial variation in crop production. The majority of the time, yield sensors are attached to various pieces of harvesting machinery. These sensors assess crop output by employing various methodologies, such as impact or load cell measurements. These sensors keep a record of the weight of the crop that has been harvested. They can also be calibrated to take into account differences in the crop's moisture content, as well as other factors that influence the estimation of yield. The system for monitoring yield gathers data not only on the yield of the crop, but also on its location, the time, and other pertinent aspects. This data is being captured and saved so that it can be analyzed and evaluated in the future. The data on the yields that were collected can be processed and examined with the use of specialized software or farm management systems. With the use of this study, patterns, trends, and variations in crop production across the field can be identified. It is possible to develop data visualization tools such as yield maps, charts, and graphs in order to gain a better understanding of the information and make more informed decisions. Number 2. Precision nutrient applicator. The term precision nutrient applicator refers to a specialized piece of agricultural equipment or tool that has been developed to accurately and efficiently apply fertilizers or other types of nutrients to crops in a manner that is targeted and specific. Precision nutrient applicators utilize variable rate technology, VRT, to apply fertilizers or nutrients at varied rates based on the precise demands of different areas within a field. This system takes into account soil nutrient levels, crop requirements, and other factors to optimize fertilizer delivery rates. Some precision nutrient applicators include sensors, such as soil nutrient sensors or crop canopy sensors, to offer real-time data on soil nutrient levels or crop nutritional status. These sensors help guide the application process, allowing for on-the-go modifications and exact nutrient placement. Precision nutrient applicators commonly incorporate Global Positioning System, GPS, and guidance technologies to provide exact and consistent nutrient administration. GPS technology gives exact location information, enabling the equipment to follow specified courses or grids and apply nutrients at the desired spots. Precision nutrition applicators can be supplied with section control mechanisms, which separate the application equipment into portions. This enables precise control over which parts receive fertilizer, eliminating overlap and lowering nutrient wastage in areas that have previously been appropriately treated. This allows for more precision in determining which sections receive fertilizer. Integration of precision nutrient applicators with mapping and data management systems enables data recording and mapping of nutrient application rates across a field. This is made possible by the fact that the systems can be used together. This information can be put to use for analysis, planning for the future, and keeping track of the history of nutrient application. Number 1. Robotic planting machine. A robotic planting machine is a specialized agricultural equipment or robot that is designed to automate the process of planting seeds or seedlings in agricultural fields. The term robotic planting machine is used interchangeably with the phrase robotic planting robot. Planting machines that are operated by robots are intended to plant seeds with as little assistance from a human as possible. They are outfitted with cutting-edge sensors, control systems, and actuators, which enable them to navigate through the field autonomously. identify planting spots, and carry out planting duties with a high degree of accuracy. Planting machines that are operated robotically are able to sow seeds or plant seedlings with a high degree of accuracy at predefined intervals and depths in the soil. They ensure that the planting spacing and depth is consistent, which is essential for the emergence and growth of the crop in an even manner. A great number of robotic planting machines are equipped with vision systems, which may take the form of cameras or 3D imaging technologies. This enables the machines to precisely identify planting places. These technologies do an analysis of the land and send real-time feedback to the robot, which enables the robot to make appropriate adjustments to its position and planting activities. Robotic planting machines make use of navigation systems like GPS and LiDAR to map out the terrain of a field and plot out the planting routes that will result in the greatest amount of crop production. Algorithms for path planning ensure that the robot will traverse the entire field while avoiding any obstructions it encounters.